We are back once again. It is an unknown number of days. I don't know who I am. I don't know where I am. I don't know what I am doing. JK, we're here to do LeetCode, but we're back once again. As you can see, my comments aren't working, so we actually will not be able to respond to. I lied. I just grabbed my phone. We'll be able to answer some comments. So from Clappy, we have, are you in a developer position? I currently am. I have about 1.7667 years of experience. Actually, that's cap. It's probably closer to 1.8. I have a question from Yasir Gauti. Do you have a CS degree, or are you still in college? I do have a CS degree. I did 4 years at a small college nearby, and I also spent another year and a half finishing a master's. So yeah, I've been in school for a while. And then we have a comment for Rohan, from Rohan. Keep going. You too, brother. Keep on going. I was doing some thinking. The thing has arrived. I ordered a Philips Hue light bulb, okay, and I have the light bulb pointed directly at the center of my cornea. And the goal is, it's a Hue light bulb. If you don't know, it's Bluetooth. You can control it and have it on a routine. Because I've been trying to wake up early recently to get more out of the mornings. This has been going okay. It's been going okay. I've been able to do my stuff closer to the beginning of the day for most of the time so far. So that's a good thing. The issue is I'd like it to be more consistent, and the barcode thing didn't really work. So pretty much I put a Philips Hue bulb into a lamp and I set it to pretty much go off 20 minutes, 30 minutes to slowly fade in before I wake up. And I have to admit, the waking up experience was truly incredible. It was an incredible experience. I surmise this is how our monkey predecessors, our ape ancestors, woke up to the beautiful rays of the sun. But basically we're going back to monkey, and yeah, it was pretty incredible. So I think that was one bulb, and the bulbs are expensive, so I might get another one and see if I can get them to all coordinate and pretty much make the room blindingly bright. And it's kind of hard to go back to sleep in that room. So that would be the goal. And yeah, I'll report back to see if it is progressing as expected. So that will be interesting. What isn't progressing as expected, however, is the Discord bot. So yeah, I had a busy day yesterday, as well as a busy day today. So I don't know when it'll be finished, but I actually haven't talked much about it. But the Discord bot is basically a bot that's going to place people. If it's pretty much you can link it. I'm going to put in Discord. I couldn't find a bot to do the same thing, but pretty much you can link your Discord account to your LeetCode account, and then you'll be given an automatic role in the Discord, the hyperbolic coding chamber, by the way, an automatic role in the Discord. And yeah, automatic role in Discord, and maybe we'll come up with some cool names, right? At the top, at the highest rank where all the questions are completed. Maybe, yeah, who knows what that role will be called? Because I'm very far from there, and I'm wondering. Be interesting to see how far other people are along. How far other people are along on questions solved. So that's pretty much the bot. The only issue is that, yeah, there has to be some data persistence because I have to pretty much sync people's accounts every day. But I thought it'd be a cool addition to the Discord. So that is what is coming. I think honestly tomorrow I have a lot of free time, so I'm just gonna bang it out, and then that would be ideal. And then after that, we might just do some. I don't know. I've been doing a lot of thinking recently. Maybe too much thinking. Maybe too much thinking indeed. In retrospect, a lot of these videos, sometimes I watch them back. It feels like I go pretty much bounce around every day on my ideas. But I feel like that happens to most of us, except maybe I'm just saying more what's on my mind, so it just comes off more bouncing aroundy. But just been thinking, the next thing you do might be a game. We shall see. I used to make a lot of games back in the day. And yeah, could be cool. I'll be using We'll see. We'll see. We'll see. I don't know if I'm that down yet. Or it had to be for the right idea. I was looking into the mobile game market. The mobile game market is a race to the bottom of the brainstem. Someone has to say it. These games, these ads, these ads for these games are crazy. There are some games like on Apple Arcade that you can tell are truly trying to push the boundary and say something, or even just make the game like not a brainstem game, but a lot of brainstem games where it's just like abusing some like strange biological like push towards like a weird thing. Like clicker games are like that. Pretty much gambling is like that. But in a weird way, clicker games are kind of flames, but there's another aspect where they are in another way not flames. So we'll have to do some thinking, but we don't have to think about doing LeetCode. So we're back once again with another dollop of LeetCode to complete. So it'll be interesting to see when we get done today. I got stuck on a problem called min cost climbing stairs, and I did some reading in the ADM, so I'm hoping that this problem can be dunked upon today. So that will be the goal. We're going to do our 1 hour as usual. Hopefully this problem can be dunked upon. Maybe I did too much ADM reading because my eyes are fried right now. They are indeed fried. I also stayed up really late. So, man, pretty much the schedule needs to make more sense. But we're back once again, and you're gonna want to make sure to join the HCC for the Discord bot when it joins, because once it starts giving out roles, it's going to be a problem. Maybe at the top role, you can just have the Discord and the channel. So you're gonna want to join the Hyperbolic Coding Chamber to be at the top of a Discord that has 300 million users. So you're gonna want to join the Discord for that. And I'm just going to jump into it today. OBS has some rendering issues when I use window-based capture, so it tends to be a little buggy. But that is a necessary evil, unfortunately, that we will simply have to battle our way through. But I'm just going to jump into it here. So we're switching to Vim, and then, so we're given an integer array cost, where cost sub I is the cost of the ith step on a staircase. Ith step on a staircase. Integer array cost, where cost sub I is the cost of the ith step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or the step with index 1. I also just realized this weird version I wrote, this should be cost length. If we can either start from. So I read the ADM. I thought this could be a weighted shortest path problem, a vertex weighted shortest path problem that we could solve using Dijkstra's or an augmented version of it. But on closer inspection, I think this can be solved with the original method if we remove some of the issues with it. My issue is with thinking about how you pay the cost. Array cost, where cost divides the cost of the ith step on a staircase. Once you pay the cost, then you can climb 1 or 2 steps. So you can either start from the step with index 0 or the step with index 1. If you start at both of those steps, it's presumed that you would already have paid the cost. So to climb, cost sol 0, 0, start at index 0. Then I did another one, so you can start at index 1. I'm trying to view the problem as a graph problem. Where as soon as you go out of bounds, you pretty much just push the weight. We end up with quite a few weights in the solutions array, so we would sort them by minimum and then return the minimum cost. In another way, we don't need these 2 calls because we can just choose, unless they're the same weight, then that would actually be a problem. So we'll keep it like this for now. So you're going in with cost and solution, which is an empty array. Cost is the number array with the costs for the steps. We're starting at index 0 with a weight of 0. Now our index, which is 0, is not greater than cost.length, so we haven't reached the end. So then we want to climb with cost sol and index plus 1 with weight plus costs of index. So then we would add 10. And we'd be at index 1. 1 isn't greater than 3. So we now do else again. And do index plus 1. Plus the weight of 1, which would give you 15. Let me go up. 3 is not greater than cost.length. So we go into else, cost, sol index plus 1, weight plus cost of index, we get plus 20. And now 4 is greater than cost.length, so we do sol.push weight. We push weight onto the solutions. I wonder what's going on with sol such that we're not getting a number at the end. Climb doesn't return anything. So if I just print sol, what's going on here? Oh, I think maybe if it's greater than or equal to, because for 45, that's when we add them all together. 30, how are we getting 30? It's not even possible to get 30. Oh no, you can get 10 and 20. So I'm wondering if the other ones is when we reach 3. These are total costs. The values that we're returning do not include 15. And I guess that would make sense since we're starting at the first one. What we could do so that we don't go through the list twice is just start our index at -1. And then when we do costs of index, we'll have to make sure that it actually exists, which is a little bit convoluted, but right, so we get a runtime error. Now, basically, I think this just means we are out of heap. Does that mean we're just basically using too much memory? Yeah, cost would be massive here. So even when we wrote this yesterday and it didn't work, we messed up programming it because of that greater than or equals sign. It seems like we were right anyway because we said we'd still run out of time in the end, which we have. I mean, we'd run out of. I thought we'd run out of time, but we ran out of space on the heap. It looks like it passed almost 260 of the test cases. It just happens to be that I'm not even certain Dijkstra's algorithm would work here. This graph is absolutely massive. Maybe it's not a graph problem. What if it's not a graph problem and we viewed it as I wonder if we tried a greedy algorithm, if we just tried a greedy version and we just did something like, hey, what if we just take the smallest cost or the locally smallest cost out of all of our options? Could that translate to the minimum path? Unless, I think we could generate a case where this wouldn't work. For example, if we did a greedy algorithm here, should we take 1 or 100? We'll take 1. Right now, should we take 100 or 1? We should take 1. Should we take 1 or 1? Right now, there's this fork in the path. If you take the first one, you end up taking 100. But if you take the second one, and this ends up being the right path. So it feels like it ends up feeling like greedy is not going to work. So if greedy is not going to work, maybe the only play is Dijkstra's algorithm, except we use the vertex weighted version. What if that is what we did? I feel like there's a simpler solution here. I feel like they wouldn't have us do... Maybe this would be an intro. I knew it was DP. Oh, man. I knew there was a DP aspect. Only because Dijkstra's algorithm, the intuition behind Dijkstra's algorithm is that it has a dynamic programming-based nature. Because the shortest path for a vertex T is made up of the shortest path, is built up from the solution of a shortest path through some vertex before T, like X. So that is unfortunate. So if it's DP, can we use... It sounds like we should just use Dijkstra's. Can we build up... So if we started from 1, DP. DP. It sounds like an introductory DP problem. Turn the minimum cost to reach the top of the floor. Build it up from the sub-solutions. What if we started top down at 20? Actually, I'd be curious to know even. Oh no, it does matter. You can, because you can go past. Going past does count. The problem is, even if you took a local path, you could say, like, oh, throw out the ones that are. For example, if we had a bunch of paths to consider, we could throw out the ones that are greater than the current weight. But it's hard to know until you get to the end if it's really the shortest weight or the least cost path. Intuition behind DP is very nutty. How to build the problem up as a. I don't even think Dijkstra's would work here. Or I think it would, but maybe we'd still end up with a blown up heap. But actually, let me check. I wonder if we're blowing up because we're using too much space in this array. If we comment out this array, we won't get the right answer. But I wonder if we still blow up. I think I need the original test case that was very large. Wait, usually there's a use as test case button. I guess we'll just copy it. Plus, sorting that many elements must be crazy. So you still get TLE. What if we didn't sort it? Oh, these are just minor optimizations because we're not really, this algorithm isn't even bounded by the sort I'm pretty sure it's... Oh, well, if we push, we don't run out of space, we run out of time. So it looks like underlying the space issue is also a time issue. Yeah, so okay, there's no point because it still wouldn't matter. But we could have removed the sort because we could just keep track of the smallest weight at the end. And yeah. Can we build up a solution based on the optimal solution of subproblems? I think is the behind the scenes goal of DP. Behind the scenes solution of You know what? Let's try the greedy version. What if we just iterate through the array? How small is my code? What if we just iterate through, and we know what? We'll say for I equals 0, I is less than cost dot length, I plus plus. We'll say min cost is going to be equal to, I think you can just say infinity actually, or return cost. Oops, we'll call it min cost. And we'll say, actually, it might just be easier if we just say let I equals 0. We'll change this to a while. We'll say while I is less than cost dot length. This way we can control how fast we move through. Because we'll say if cost sub I is less we'll try the greedy version. So we'll start at I -1 like before. We'll say if cost sub I plus 1 is less than cost sub I plus 2, then we'll say I plus equal 1, right? And min cost plus equal cost sub I plus 1. And the opposite, okay? The opposite can be our case. So we start at 10 or 15. We'd say we start at -1, and we'd say, okay, is 10 or 15 less? Well, which one is less? 10. So we take 10. Yeah, it already doesn't work on the first case. I think we already said that the greedy wouldn't work. What if we just what if we ran it twice? Except we didn't use min cost. We'd redeclare it, and this time we'd start at index 1. This one starts at index 0. Then we just have cur cost equals infinity, min cost equals infinity. And then at the end of both, we would say min cost equals math.min of cur cost and min cost. Probably want cur cost to start at 0. So cur cost will start at 0, min cost starts at infinity. We add some value. At the end of the whole thing, we'd say min infinity or cur cost. At the end, we'd say min or whatever min cost was, and now what cur cost started at, which should be 0, going up to some value. I think the issue here is that now that we're starting at the index itself, we don't need to do I and I plus 2 because that's going to break the value. Okay, maybe not. Let me sit here and look at them. Cur cost equals 0, I equals 0, I is less than cost.length. If cost of I is less than cost of I plus 1, I plus 1 cur cost plus I. Let's see what cost of I. Otherwise, I plus equal 2. Oh, I see what's going on. I think we're adding too soon. We should be adding after. We're still getting none. What is going on? Equals 0. I is less than cost at length. So if 10 is less than 15, cur cost plus equals 10. Then we do I plus equal 1. Then we go to 15. Okay, is 15 less than 20? Not understanding why the values don't exist. You get 25. Then we do have cost sub I, which is 20. Oh, wait, I'm so confused. If we get 1 and then 2, zero is less than 3. Is 10 less than 15? So we add 10, we increase by 1. Now we're at 15. Is 15 less than or equal to 20? We add 15, we get 25. Then we add 1. Now we're at 25. 3. No, we're at 2. Is 2 less than 3? It is. So we see if cost sub I, which is 20 less than this. No, so we do plus equal cost of I plus 1. I'm already certain this doesn't work. Because we're always grabbing this closest one, but sometimes you can just skip over and go to the end. So we could add another case. We could say if I plus or if I plus 1 or I plus, basically if cost dot length minus 2 which would be 1. Basically, if we can add 2 and just go to the end, then we want to do that. So we just say if I plus 2 is greater than cost dot length, we can just say break. This is very ghetto. I should have just wrote this in a function, but it is what it is. Yeah, DP is, I think, my worst. 3, 4. So the indexes we're hitting are 1, 3, 5, 7, and 8. 1, 2, 3, 5, 7, 0, 1, 2, 3, 4, 5, 6, 7. Nine. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I see what's happening here. If the value is out of bounds, it should default to infinity. Oh no, we actually are getting the correct value because we're getting 6 as our cost. Then we run it again starting at 100. And we end up in 5, which is not possible. So if I, which is 100, well, you have to start at that value, so you have to start with that current cost. But you're really choosing one is starting from 100, or if you start at 1, you're basically choosing between 100 and 1. If you start at 100, you're basically choosing between between 2, 0, yeah, between 2 and 3. I think this 2 version is just a bit nutty. What if we said if cost sub 0 is less than cost sub 1, you want to start at index 0, otherwise you want to start at index 1. Then cur cost is going to start you at I. And then we'll do I plus equal 1, which would pretty much give us the same answer as before. Yeah, the problem is, with 15, we already know this one doesn't work, but I'm trying it anyway. I'm not... DP is like my worst. Build an array DP, where DP sub I is the minimum cost to climb to the top starting from the ith staircase. Let's take that first hint and delete all this garbage. So build an array DP where DP sub I is the minimum cost to climb to the top starting from the ith staircase. And then you can just iterate through and choose the lowest cost path throughout the whole thing. Minimum cost to climb to the top starting from the ith staircase. Build an array DP where DP sub I is the minimum cost to climb to the top. This makes sense. Even though, even here, you still wouldn't be able to, as the minimum cost. If you had that DP array, could you just iterate through and choose the minimum cost? I think you could afterwards just choose. No, actually, I think you could just iterate through and use the greedy method afterwards. Build an array DP where DP sub I is the minimum cost to climb. So what if we took a you're giving it a cost. Given an integer array cost where cost of I is the cost of ith step on a staircase. Once you pay the cost, build an array dp where dp sub I is the minimum cost to climb to the top. How would you get the minimum cost to climb the top starting from the ith staircase? Build an array dp where dp sub I is the minimum cost to climb to the top starting from the ith staircase. The whole way. Build an array dp or dp. Yeah, this problem. I think I need to do some reading in the ADM about dynamic programming, because I don't even know where to start. Build an array, but I think this is important. Afterwards, you can just choose local min because each local min has been encoded with the steps to get to the end. I'm trying to come up with an algorithm where you don't visit all the paths, but even in Dijkstra's algorithm, you do visit every path. You generate all the paths, all the minimum paths. Yeah, another reason this problem gives me a lot of trouble is because these shortest path problems always give me an issue, whether it's based on distance, like number of vertices, or weight. Examples being climbing stairs, coin change. There's quite a few in there. You can store all this information in space that doesn't scale too crazily and with n squared time. You can view this problem as a vertex-weighted graph. Vertex-weighted graph, you need a couple of things. The graph, you don't need the degree. You do need an adjacency list. Let's try two approaches first. DP-based solution. And then we'll try Dijkstra's, which should be possible. For that, we need an adjacency list. So we need a way to turn cost into an adjacency list, or we can just make it implicitly an adjacency list. It's an adjacency list. What else do we need access to? We'd also need access to a parent array. Actually, we wouldn't exactly need access to the parent array, because that would be if we wanted to know the shortest path, we wanted to know the minimum cost. So we'd create a distance array, which would be an array of numbers. Because it would store the distance, the weight of the shortest distance, pretty much the weight, the total weight to get to, starting from S to T, is what distance would store, where distance sub T would be the starting index. I'm pretty certain n vertices would be equal to cost dot length, and so we'd say I is equal to 0, I is less than n vertices, I plus plus. We'd probably want to set all the distances equal to math. To infinity. We need to be able to visit adjacent elements. We can do that by just visiting the next two indices, I and I plus 1. So this works in layers. For each layer, for each node, we want to compute the shortest path to T. By building the tree, so we could have another array, we'll call it in tree, and it's just going to be a Boolean array as well. We're just going to put in tree dot push false for each vertex. Oh, I guess we'll just call it a Boolean array. That we'll know if something's in the tree. So we finally show this path by slowly building the tree. Yeah, I'm going to have to reread that page on Dijkstra's, and then we'll have to come back to this problem. This one is beastly, but it's good for an easy, because if I ran into this in a DP of this on a medium problem, there's no way I'm solving it, or a hard problem.